Alright, so today we're going to talk about specific types of angles and how they relate to parallel lines. So, corresponding angles postulate. This tells us if two parallel lines are cut by a transversal, then each pair of corresponding angles is congruent. So, corresponding angles would be like angles 1 and 5, 2 and 6, 7 and 3, and 4 and 8. Those will all be your corresponding angles. Again, the key characteristic, they have to be on the same side of your transversal, and they have to be both one of them inside the two parallel lines, one outside them. They essentially, one way to look at it, they'll form an F. Angles inside that F would be corresponding angles, and then however you orient the F. Same is true for your alternate interior angles. If you have two parallel lines, again, cut by a transversal, each pair of alternate interior angles are going to be congruent. So 4 and 6 would be congruent, then 3 and 5 would be congruent. Because those are our alternate interior angles for this particular diagram. Alternate exterior angles, again, also congruent. You're noticing a lot of patterns here. We have a lot of congruent angles when we have parallel lines. So 1 and 7 would be equal to each other, and then 2 and 8 would be equal to each other. And then our last one, these are not congruent now, but they are supplementary. Our consecutive interior angles, 3 and 6, or 4 and 5, will add up to 180 degrees, because they will be supplementary angles. And these last three, your consecutive interior angles, your alternate interior angles, and your alternate exterior angles, we will prove at a later date why they are true for if the lines are parallel, why they're congruent or supplementary, and then also the opposites. If angles happen to be congruent or happen to be supplementary, does that prove the lines are parallel? So first let's start with an example. So let's fill in this diagram. So we have x, 140 degrees, and y. So we want to solve for these angles, and we're told that these two lines right here are both parallel, and that's what the arrows are going to mean. Well, notice x and 140 both represent corresponding angles. If they're corresponding, that means they're equal. So x equals 140, and that part is done. Now, there is no particular relationship between x and y based on any of our actual angles. This is not a corresponding angle relationship. It's not alternate interior, alternate exterior, consecutive interior. However, you should recognize between y and 140, they're a linear pair. So y plus 140 equals 180. So I can subtract 140 from both sides. Y should equal 40 degrees. One thing you'll notice with these parallel lines, are to draw it looking like this. We have four big angles that are in these parallel lines, and four small angles, just by how it looks. Each one of the big angles has to equal the other big angles. So big angles always equal big angles. Small angles always equal small angles. And any big angle you find plus any small angle you find has to be 180 degrees. Whether they're one of our actual relationships we discussed or whether they're not. Has to always, always, always be true. So you can use this concept. Again, the key is they have to be parallel lines. If they're not parallel lines, this is not true, and we have to do other stuff. So keep that in mind. So we have this diagram. So we have 8x minus 13 right here, and then 3x plus 12 here. So these two angles are what we call alternate interior angles, because they're both inside our two parallel lines, and they're on opposite sides of the transversal. Since they're alternate interior, they must equal each other. So 8x minus 13 equals 3x plus 12. So we subtract 3x from both sides. We get 5x minus 13 equals 12. Add 13 to both sides. 5x equals 25. Last step, divide by 5. And you get x to equal 5. So like we saw in the previous chapter, like we're seeing all year long, the key is setting up your own linear equation and solving using your Algebra 1 skills. We have alternate interior angles, that's why we know they're equal. With these parallel line problems, and actually quite honestly with most angle problems, the angles are either going to equal each other or they're going to have to add to something. So keep that in mind. So I want you to go ahead and solve this one on your own using what we've talked about. This angle is 5z minus 10. This angle over here is 68 degrees. So go ahead and use what we've discussed to solve for z. So go ahead and pause the video while you work that out. Alright, you should find that z equals 24.4. And there are a couple different ways you could have gone about doing that. One way is to recognize if this is 68 degrees, so is this angle right here. And now these two angles, while we didn't originally have a relation between 5z minus 10 and this 68, between this 68 and the 5z minus 10, we now have consecutive interior angles. So they can add equal 180, solve for z, you'll get 24.4. You also could recognize that this angle right here was 68. So therefore we again have a 180 relationship because it's a linear pair, whether this one is 68. All three of those would have worked out fine. To give you the exact same concept, it adds to 180 with the 68. Or you could figure what this angle is missing right here, again knowing this is a linear pair. So this angle plus this angle has to be 180, this should be 112, and then the 112 and the 5z minus 10 are both equal because they're corresponding angles. Either way, no matter how you set it up, you will get 24.4 for your answer. Now they don't have to always look like the same two lines with a line across it like that. The key is as long as you recognize your parallel lines, you have to be able to identify which ones are consecutive interior, alternate exterior, corresponding angles. So we have this relationship right here. One angle is x squared plus 4x, the other one is 5x plus 144. So we have these two parallel lines, and we essentially have this transversal, if I were to extend it. So if that's my transversal, these two angles are both on the same side as it, and on the inside my two parallel lines. That makes them consecutive interior angles, so therefore they have to add to be 180 degrees. So what we're dealing with in this case is a quadratic equation. So the first thing we should do with all our equations is to combine like terms. So x squared plus 9x plus 144 equals 180. And now in this particular case, to solve quadratics, since we can't combine the x and the x squared, we have to set the whole thing equal to 0 and factor. Subtract 180 from both sides. X squared plus 9x minus 36 equals 180. So now we just try and set up two factors. So since it's x squared, the first two spots are both x's. The negative 36 tells us we have a positive and a negative number. Something positive times negative will get us a negative 36, and that's what these two last terms will give us. So we ask ourselves, what two numbers multiply to be 36, but then subtract to be 9? The answer would be 12 and 3. 12 is the positive one because it's a plus 9x. So we get x equal negative 12 and a positive 3. Now, you have to be careful. Because we deal with x squared, you need to actually check both of these answers. Whenever you have quadratics, you need to plug them back in to verify they will work out correctly. Don't plug them back into this equation because you're guaranteed to get 180 equals 180. It is theoretically possible these kind of problems, other equations, to plug it back in and get one angle that's bigger than 180 and one angle that's less than 0 degrees. We can't have that, so that's what we plug back in. So we plug in the negative 12. Well, negative 12 squared plus 4 times negative 12. 144, it's a positive, so we square negatives to get positive. Minus 48 is 96. That seems fine. 5 times negative 12 plus 144 is negative 60 plus 144, which is 84. And that's fine. They both add to 180. We're good. Plug in 3. 3 squared plus 4 times 3. 9 plus 12 equals 21. That seems fine. And then 5 times 3 plus 144. 15 plus 144 is 159. And that seems okay. And again, they both add to 180. So negative 12 and 3 are both solutions. And that's fine. So you must always plug your quadratic answers back in to verify they still work out, because you will see problems later on that don't. Now, last example. We have this diagram, and let me fill in the blanks. This angle right here is x. This is 32 degrees. This is 70 degrees. And these two lines are parallel. We want to solve for x. Now, we do not have any of our typical alternate interior corresponding alternate exterior angles, types of angles, because this is not the same transversal as this one. So they're not related. We don't have the exact same transversal. I could draw one through the two parallel lines, but that would not be what x is. However, if I were to draw this dotted line and say it's parallel to the top and bottom lines, then I can solve this problem. Because if this line is parallel to this top line, it also must be parallel to the bottom line, which is the property of parallel lines. If it's parallel to one, it's parallel to them all. And now we notice between this angle right here and the top part of angle x, these are both corresponding angles. Therefore, they're both the same. So this would also be 32 degrees. And then between the 70 degrees and the bottom part of the x, we also have another pair of corresponding angles. So this would also be 70 degrees. And these two angles make up angle x, so x has to be 32 plus 70, which is 102 degrees. So the key for solving problems similar to this, draw a dotted line through the vertex right there to form a third parallel line, and identify which angles are equal, or on the particular problems, if I gave you this angle right here instead of 32, which angles are consecutive interior. So I have to apply your different properties. Okay, so I will see you next time. Again, continue to talk about different angle and then line relationships.